So in this video, we're going to talk about the concept of polarity. More specifically, after watching this video, you should be able to determine whether a bond is polar or nonpolar. So before we start figuring out if bonds are polar or nonpolar, let's define these terms. Polar. A bond is polar if it has an uneven distribution of charge. So essentially what this means is a molecule is polar if it has charge. If it has a positive side and a negative side. And this is only true if it's also covalent. Because we have learned that ionic compounds can be, that have positive and negative charges. Here we're talking about, maybe more specifically we should say, whether a covalent bond is polar or nonpolar. Let's think about how can we remember this. Well, think about the word polar. Some examples we talked about in class. Bipolar, people who are bipolar have typically big mood swings. They're very, very happy or very, very sad, kind of opposites. Polar, or the poles on the planet. You have the north and the south pole, opposite ends. In a polar molecule, we have opposite ends, and those opposites are opposite charges, positive and negative. A nonpolar molecule, all we've done here is put the prefix non, which means not. So it's not polar. It has an even distribution of charge. So another way of saying that is that there are no positive and negative sides. The whole molecule is entirely neutral. So now that we know what these two terms mean, how do we actually figure out if a bond is polar or nonpolar? Well, in order to do this, we need to know the electronegativities of elements. So what we have here is an electronegativity scale. For every element, we have the electronegativity of that element. And as we can see, should be a review, as we go up and to the right on the periodic table, electronegativity increases. In order to figure out how polar a bond is, we need to get the difference in the electronegativities between those two elements. So for example, let's say we wanted to know if a carbon-nitrogen bond was polar. We need to find the electronegativities of those elements. So carbon has an electronegativity of 2.5, and nitrogen has an electronegativity of 3.0. So the difference between these two, remember difference in math means subtract. Always do the bigger number minus the smaller number. So 3.0 minus 2.5, 0.5. So what this is saying is the electronegativity is not equal. One of these elements wants electrons more than the other. That element is nitrogen because it has a greater electronegativity. So since this is greater than 0, that means this molecule is polar. So when we figure out the difference in electronegativities, if it's greater than 0, that means the molecule is polar. So, another example, is a CF bond polar or nonpolar? If it is polar, what element has a negative charge? So, here we're talking about carbon and fluorine. So let's go back to our electronegativity table. Here's carbon, it has an electronegativity of 2.5, fluorine 4.0. So the difference here would be 4.0 minus 2.5, 1.5. This is greater than 0, so yes, this molecule would be polar. Now the question is, if it is polar, which we said it is, which element has a negative charge? So the element with the negative charge is going to be the element that's more electronegative, because that means it wants electrons more. So which one of these elements is more electronegative? Clearly fluorine. So fluorine would be negative. Let's go ahead and try another problem. Would you expect a CO bond or a CN bond to be more polar? Explain. So, when we're doing this type of problem, there's two ways we could do it. Number one is with the numbers, meaning the electronegativities. But number two, we can do it just with the periodic table. So let's do it with just the periodic table first. We have a CO bond and we have a CN bond. which one's going to be more polar? Which one's going to have a more uneven distribution of charge? So to do that, we need to figure out which elements have a bigger difference in electronegativity. So we could either be comparing C and N or C and O. C and O. Basically, in order to figure this out just with the periodic table, we want to figure out which elements are further away from each other on the periodic table. So elements that are further away, further apart, will equal more polar. So on the periodic table here, C and O are clearly farther apart than C and N, which means the difference in electronegativities will be greater. So we would predict the CO bond to be more polar. Let's prove it by getting the numbers. So carbon, electronegativity, we should have it kind of known by now, 2.5. For O, 3.5. Here we have carbon 2.5, and for nitrogen 3.0. So let's get the difference between these two. Difference between these two numbers, 3.5 minus 2.5 is 1.0. And here the difference between these is 0.5. So clearly, CO has a bigger electronegativity difference, so it's going to be more polar, which is exactly what we predicted just using the periodic table.